Hello everyone, in today's section 2.3 we're going to learn how to calculate limits using limit laws. At first, suppose that c is a constant and the limits of the function f and g, they both exist as x goes to a. We're gonna have these 5 limit laws. The first one is the sum law. It says that the limit of the sum is the sum of the limits. And the second one is the difference law. It says the limit of a difference is the difference of the limits. And the third one says that the limit of a constant times the function f, or any function, is the constant times the limit of the function. The fourth one is the product rule, or law. The limit of a product is the product of the limits. And the final one we have here, and the fifth one is the quotient law, that the limit of the quotient is the quotient of the limits, provided that the limit of the denominator is not equal to 0. And we have here the power law. It says that when the function is power to something, we can just take the limit inside and take the power of the limit. Here is the first example. It says use the limit laws and the graphs of function f and g in this figure to evaluate the following limits if they exist. So using the limit laws, we're going to distribute the limit for a. We're going to have limit of the function f as x goes to minus 2 plus 5 limit of the function g as x goes to minus 2. When we can go to the graph here, we can see that the function f is the pink graph. So where is x minus 2? It will be here. We can clearly see that the limit from the right and from the left is equal to each other, and it's equal to 1. So I'm gonna say that the limit of the function as x goes to minus 2 is 1, plus the constant 5. So what's the limit of the function g when x goes to minus 2? Here is the function g, here is minus 2, and here is the function g. I can go down there and clearly see that the limit of the function g from the right and from the left is equal to each other, and it's equal to minus 1. So we're gonna have is 1 plus 5 times minus 1, and this gives us minus 4. For part B, it says or asks about the limit of the function f times g of x when x goes to 1. I can use the limit law here, the product law, and distribute the limit of the function f times the limit of the function g as x goes to 1 for both limits. Now we can check the limit of the function f as x goes to 1. Here is the 1, and here is the function f. It's clear that the limit of the function f from the right and from the left is equal to 2. So I can write here that the limit of the function f as x goes to 1 is 2. But here's the thing, here's the problem, that when we're gonna check the limit of the function g as x goes to 1, it's clear that from the right and from the left they are different. Like, we can distribute it like this and say that the limit of the function g as x goes to 1 from the right is equal to minus 1, and from the left as x goes to 1 from the left, is equal to, here it is, minus 2. So we can clearly see that the limit from the right and from the left, they are not equal to each other. Therefore, the product of the function f and g, if we take the limit as x goes to 1, does not exist, because the limit of the g as x goes to 1 does not exist. Now for part C, it's asking about the limit of the function f over g of x as x goes to 2. So we can use the limit law, the quotient law, and distribute the limit of f of x as x goes to 2 over limit of g of x as x goes to 2. So now let's go to the graph and see the function f when x goes to 2. Here it is. It's clearly here. We can say that it's like around 1.5, because from the left and from the right they are equal to each other, and we can say that the limit of the function of f of x is equal to 1.5, and the limit of the function g as x goes to 2, it's just right here, is equal to 0. Because the limit of the denominator is 0, we can't use law 5. So the given limit does not exist because the denominator approaches 0 while the numerator approaches a non-zero number. Here we have some more laws that we need to know, that the limit of the constant, whatever it is, when x goes to whatever a it is, it's just the constant. And the limit of the function x to power 1 as x goes to a is equal to a. It's like a direct substitution. And when the limit of a polynomial where n is a positive integer as x goes to a, just equal to a to power n. And the limit of the square root of x, square root or any root of x, and n is a positive integer, this is equal to the square root or any root of the constant a, because x goes to a. And the limit of the root of the function when n is also positive integer, just be equal to the root of the limit of the function. We can just take the limit inside the root. Here we have example 2. It says evaluate the following limits and justify each step. So let's start with a. We're gonna use the limit laws here. Okay, for a, we can use law 2 and law 1 by distributing the limit, because it's addition and subtraction. So limit of 2x squared as x goes to 5 minus limit of 3x as x goes to 5 plus limit of 4 as x goes to 5. And now we can use law 3, that's multiplying by constant, and take the constant out. It will be 2 times the limit of x squared as x goes to 5 minus 3 limit of x as x goes to 5 plus limit of 4 as x goes to 5. And by law 9, 8, and 7, we can just substitute the 5 in the x squared. This will give us 5 squared minus 3 times 5, just substitute the 5 in the x, plus the limit of the constant, just the constant, which is 4. This will give us the final answer, which is 39. Okay, what about b? In part b, we will start by using the law 5, the quotient law, but its use is fully justified only at the final stage when we see that the limits of the numerator and denominator exist, and the limit of the denominator is not equal to 0. So now let's start. For part B, I'll use law 5 and law 1, 2, and 3. First, I will use law 5 by distributing the limit to the numerator and the denominator. And then I will use the law 1 and 2, the addition and subtraction law. So I will have limit of x to power 3 as x goes to minus 2 plus limit of 2x squared as x goes to minus 2 minus limit of 1 as x goes to minus 2 over limit of 5 as x goes to minus 2 minus limit of 3 of x as x goes to minus 2. And by law 3, that's multiplied by the constant, I just can take this constant out. So what we're gonna have is equal to limit x cubed plus 2 limit x squared minus limit 1 as x goes to minus 2 over limit of 5 as x goes to minus 2 minus 3 limit x as x goes to minus 2. Now I just can use law 8 and 9 and 7 and do the direct substitution of minus 2 in the x to power 3. This will give us minus 2 to power 3 plus 2 times minus 2 to power 2 minus the limit of the constant adjust itself, minus 1 over 5 minus 3 times minus 2. This will give us minus 1 over 11.